Hi, my name's Grant Sullivan. I'm the president of Nihtat Energy Limited. We're an energy-based company out of Inuvik, Northwest Territories. The hamlet of Aklavik reached out to me and they wanted to look at building solar projects for their cabins. So while this system was being developed for cabin owners in the Beaufort Delta, which are very remote and hard to get to, there's a lot of application to other cabin owners in other locations. What I'm going to show you today is how simple the Yeti 3000 system actually is to operate, how we can charge it, and what the typical load will look like on this system, and how cabin owners can actively manage that load and how they actually use that energy. So this is the Yeti 3000X Goal Zero battery. It has the inverter already in it, which makes this a huge advantage. It's a battery inverter package, which is great. And the nice thing is there's multiple ports on here. There's your inputs and then your output ports. So it's very familiar to see, like for a lot of people, how they run this thing. So there's three ways you can charge your battery system. The first being just the charging system that comes with the unit itself, which is plugs directly into your wall outlet and through an Anderson cable, which is clearly marked red and black. The nice thing, once again, with the system is it's plug and play. So that's the only port that unit can go into. So that system there will charge the unit at about 220 watts. So that's what the power is going into the system. The nice thing with this system is you can also charge this off a generator. Goal Zero does have a 600 watt fast charging system. So I would recommend using the fast charging system at the cabin with a generator. And then finally, of course, the preferred option is to use a solar panel. And once again, it's the same Anderson cable that fits directly into your port. The solar system, you can add up to a maximum of 600 watts of solar that can safely go into the system at one shot. Obviously, the more panels you have, the faster this will charge. The really interesting part about this unit is this screen right here that shows how much energy is coming in and how much energy is going out. And why that's really interesting is because that puts a lot of control in the cabin owner's hands. I'm going to give you an example of how we can visually see how cabin owners can actively manage their load. So what I've done is I have 10 regular lights. So these are the lights, they're not LEDs, these are the standard 100 watt lights. So there's 10 of these bulbs here. So each one of these bulbs is 100 watts. So this actually equates to 1 kilowatt hour. And so there's 3,000 watts in this unit, and this is 1,000 watts per hour. So you can see when you plug this in, we're drawing around 817 watts. The unit itself will actually tell you how many hours of operation you have left. What I'm going to do now is I'm going to change these light bulbs over to LED light bulbs, and I can show you how much longer your system can run for. So I've changed over the bulbs. So these are all 100 watt bulbs, but they actually draw around 15 watts per bulb. So they're putting out the same amount of lumens as the previous bulbs, but they just consume that much less energy. As you can see, the battery is only being drawn 136 watts. So you compare it to the 800 watts that the regular bulbs are doing. So this shows how cabin owners can actively manage their load and how long they can actually run this battery system. When we were looking at the cabin, we were trying to decide what are the essential items that cabin owners have today. Most cabins today, people use their cell phones and laptops pretty consistently. And so I wanted to show how to charge these systems. So the Goal Zero does have USB ports already built into the system. And it's important you actually use the USB ports as opposed to using the adapter that comes with your phone to charge off the AC current. So what is happening is you have a DC battery, and in your phone there's a DC battery as well. So if you're using the USB ports, it's going DC to DC, and so you gain a better efficiency than you would using an AC adapter into a DC phone. And charging the phone is taking around 11 watts. And then I can add in the laptop as well. So right now I'm at about 42 watts for the combined of these two units here. So most cabin owners today have a television as part of their cabins as well. So this is just a regular 40-inch television. It's smaller in size, but a good size for cabins. So the television is drawing around 31 watts, which equates to about a 66-hour runtime. Most cabin owners today need to have a fridge. The fridge itself has a refrigerator and a freezer component in the fridge. It's a smaller size fridge, but the energy efficiency was quite high. When you plug this fridge into the system, it's drawing about 136 watts. This next item on the list is a sewing machine, and this was a special request of my mother, who sews quite a bit at her cabin. Just the bulb right now is pulling 20 watts. And then so if we start using the machine, that peaked at 67 watts draw. That's without fabric. So we're around 80 watts to run this sewing machine just by itself. So the battery pack can manage this type of surge, which is great because the Goal Zero is strong enough to actually manage that. It does consume a lot of energy. There's so many more battery operated tools out there. I think everybody has a cordless drill, cordless skill saw, cordless battery operated chainsaw, and it's actually a proper chainsaw. I've actually used this, it actually works. So for the days when you have this unit at your cabin and you have a good solar radiance day, that's when you want to charge these batteries up, because it's additional storage basically. When you have excess watts, you always want to make sure you use them. If your battery is full, how do you get the most out of them? And that's when you can start looking at your different battery operated tools like these, when you can start plugging them in to actually really maximize the solar gains you're getting. So this is drawing 204 watts, which on a solar radiance day, that's actually doable with a good solar radiance day to actually be charging these directly from the solar. One of the items that are getting a lot more popular are electric e-bikes. So this is currently pulling 136 watts. So the battery pack is a big battery pack on the e-bikes. But once again, though, if the cabin owners actively manage their system on how they want to run it and when they want to charge specific items, this is a reality. Like, you can get a piece of transportation off this system in a remote location. So now that we've kind of gone through all the units by themselves, we're looking at what would actually operate in a cabin on the day-to-day. I have everything plugged into a power bar here, which is attached into the unit, other than my cell phone, which is through the USB. So with everything plugged on, the TV, laptop, iPhone, 4 light bulbs, and the refrigerator, we're consuming around 121 watts. And the battery at 100% charge will run for approximately 22 hours. So everyone will end up using this system in a different way. What I've tried to demonstrate here is a typical cabin and what I would think would be used at a cabin. But what I think the system is really showing here is there are alternatives than a traditional generator running 24/7 with noise and fumes, that a system like this can actually operate the bulk of your needs at a cabin. This is just one good example of how to green up a cabin in a remote location.